Assuming we clear out the lines, the most entrancing star I perceive is the one that could puzzle our sky. It is this one, scarab juice or scarab pound. It's a red, exceptionally gigantic star. On the off chance that you put it where the sun is, it would stretch out to the orbit of Jupiter. It's colossal, totally unusual, and going to detonate. It's not generally as clear as it seems to be in the universe. These giant events, like the massive, generally feared starbursts, could shake all that we see, and even things we fail to notice. Its core, Betelgeuse, has been observed as a red, incredibly giant star. It is significantly larger than our Sun. Brian Cox and other space experts speculate that it could go supernova, which has made individuals worry about what will happen next. The James Webb Space Telescope is taking stunning photos of the star, raising the question of when Betelgeuse will transform into a supernova and what titanic influence it will have on Earth. We should analyze the star in the radiant constellation Orion, which shines so brightly that even ancient humans noticed it. The star Betelgeuse is located on the eastern shoulder of Orion. It is the second largest star in this constellation, and its name reflects this position as the Beast's Shoulder. Betelgeuse is one of the brightest stars in the night sky. In addition to its brilliance, it has an odd red hue, which, as we will see, suggests trouble. Humans have observed Betelgeuse for centuries. A Greek observer named Tmy once described it as frog-stool-colored orange. In modern times, experts have focused more intently on the star. They now have a clearer idea of what makes it so intriguing. One such characteristic is the star's variability in brightness, with a notable range of 0.6 magnitudes. Betelgeuse is a variable star, meaning its brightness changes over time. In 2019, experts observed something unusual about Betelgeuse. Although it didn't stop shining altogether, its brightness dropped significantly, reaching a magnitude of 1.6. This unusual dimming raised questions among researchers, leading to speculation that Betelgeuse could go supernova at any moment. Renowned physicist Brian Cox noted that Betelgeuse behaves like a ticking time bomb due to its potential for an unannounced explosion. The James Webb Space Telescope has provided substantial evidence to support these concerns. What unconventional signs has Betelgeuse exhibited to cause such alarm in the scientific community? The star has been classified as a supernova candidate, primarily due to its mass, which is twice that of the Sun. For a star to go supernova, it must have several times the mass of the Sun. Researchers have used advanced tools like the James Webb Space Telescope and the Laser Interferometer Gravitational Wave Observatory to study Betelgeuse. The findings remain a mystery. On August 31st, scientists identified peculiar light waves emanating from the star, further complicating predictions about its future. This brings us back to the possibility that Betelgeuse's fluctuating brightness indicates instability. It dims and brightens at irregular intervals. In February 2021, its brightness dropped to an unprecedented 1.61 magnitude. This dimming was preceded by a great dimming event observed in 2019, which marked the beginning of Betelgeuse's erratic behavior. Astrophysicist Andrea Dupree at the Harvard-Smithsonian Center for Astrophysics noted that Betelgeuse became 150% brighter than normal following its dimming, making it the seventh brightest star in the sky. This brightness has led scientists to reconsider their earlier conclusions about the star's fate. Betelgeuse is a red supergiant star, the final phase of a star's life. Its red hue stems from a surface temperature of around 3,500 Kelvin, significantly cooler than the Sun's 5,500 Kelvin. Despite its cooler temperature, Betelgeuse's massiveness suggests it will eventually explode. Scientists are using advanced telescopes, including the James Webb Space Telescope, to monitor Betelgeuse's behavior. Observations have revealed dust clouds forming on the star's surface, resembling leaves in space. These findings suggest significant mass ejections from the star. When Betelgeuse finally explodes, it will release an immense amount of energy, momentarily outshining the entire universe. From Earth, the supernova will appear as bright as the full moon. However, at 600 light-years away, it poses no immediate threat to our planet. The death of a star like Betelgeuse is a transformative event, enriching the cosmos with elements necessary for new stars, planets, and potentially life. Its eventual explosion will mark the end of one celestial cycle and the beginning of another. Until then, scientists continue to observe Betelgeuse, unraveling its mysteries and expanding our understanding of the universe. Its transformation from a red supergiant to a supernova will be one of the most extraordinary cosmic events witnessed by humanity. Monumental phenomenon. They are continuously unraveling the mysteries surrounding Betelgeuse's ultimate fate. While we watch and wait, the possibility of witnessing such a rare event keeps astronomers, physicists, and enthusiasts captivated. The study of Betelgeuse offers a significant opportunity to expand our understanding of cosmic life cycles. The data obtained through the star's behavior could illuminate processes that occur in stars much larger than our Sun, shaping the broader understanding of the universe. For instance, stars like Betelgeuse produce and disperse elements like carbon, oxygen, and nitrogen during their violent deaths. These elements are critical to the formation of planets and life itself, thus making stars the true cosmic forges of creation. Betelgeuse has already provided many surprises. Observations show that it has shed large quantities of mass over time, resulting in clouds of gas and dust that may obscure parts of the star's light. These events have prompted astronomers to investigate how stars lose their outer layers during their final stages. This loss of mass significantly affects a star's final collapse and the resulting cosmic explosion, making it a key area of study for understanding supernovae mechanics. Another fascinating aspect of Betelgeuse is its variable brightness, a characteristic that has puzzled scientists for centuries. The dimming event in 2019, known as the Great Dimming, was later attributed to a combination of a surface temperature drop and a dust cloud expelled by the star. However, it also hinted at internal changes within the star itself. These revelations have heightened the anticipation of what may come next. If Betelgeuse does go supernova, its brilliance will outshine everything in the night sky, rivaling the moon for a few weeks. This will not only be a breathtaking sight for observers on Earth, but also a chance for astronomers to directly study a stellar explosion's effects on surrounding space. Such observations could also provide clues about other similar stars nearing the end of their life cycles. Despite the excitement, researchers are cautious. Predicting the exact timeline for Betelgeuse's explosion is extremely difficult due to the many unknowns in stellar physics. It's also worth noting that 600 light-years, while distant enough to prevent any harmful effects on Earth, still places Betelgeuse relatively close on a cosmic scale. The supernova's remnants will expand outward, influencing the surrounding interstellar medium and possibly triggering the formation of new stars in its wake. In many ways, Betelgeuse represents the dynamic and transient nature of the cosmos, a reminder that even the most massive and enduring celestial objects eventually meet their end. As technology advances, our ability to monitor and understand these processes deepens. Instruments like the James Webb Space Telescope, the Hubble Space Telescope, and the forthcoming extremely large telescope promise to unlock even more secrets about Betelgeuse and other stars on the brink of transformation. Until the day of Betelgeuse's inevitable supernova, we can only continue to marvel at its immense size, fiery red hue, and enigmatic behavior. Whether it happens tomorrow or in thousands of years, the legacy of this stellar giant will be one of discovery, knowledge, and wonder. In its final blaze of glory, Betelgeuse will leave an indelible mark not just on the universe, but also on our collective quest to understand the cosmos. The supernova of Betelgeuse will not just be an astronomical event. It will serve as a profound educational moment for humanity. This monumental occurrence will allow scientists to test and refine theories about the life cycles of massive stars, shedding light on how elements critical for life are dispersed throughout the galaxy. When Betelgeuse does explode, the supernova will also produce a dense core remnant. Depending on its mass, this remnant could either become a neutron star or, if massive enough, collapse further into a black hole. Both outcomes are significant for astrophysics. Neutron stars, which are composed almost entirely of neutrons, are incredibly dense and possess extreme gravitational and magnetic fields, offering unique laboratories to study the physics of matter under such intense conditions. If Betelgeuse forms a black hole, it would provide an opportunity to observe the formation of these enigmatic entities in real time. The shock waves from the supernova will ripple through the interstellar medium, compressing gas and dust in its path. This process can stimulate the formation of new stars and planetary systems, contributing to the ongoing cycle of creation and destruction that defines the universe. The material expelled during the explosion will enrich the surrounding space with heavy elements, which could eventually become part of future stars, planets, and potentially even life forms. One intriguing aspect of Betelgeuse's final act is its potential impact on our night sky. For weeks or even months, the supernova will be visible to the naked eye, turning night into a spectacle. Ancient civilizations often interpreted such cosmic phenomena as omens or signs from the heavens. Today, they are celebrated as natural wonders and a testament to the dynamic processes that govern the universe. Astronomers are already planning for this event, preparing ground and space-based observatories to capture as much data as possible. Telescopes equipped to observe various wavelengths, from gamma rays to radio waves, will be directed at Betelgeuse to record the explosion's every stage. This will include studying the initial burst of neutrinos, subatomic particles released during the collapse of the star's core, which could provide crucial information about the inner workings of massive stars. Public interest in Betelgeuse's fate has also surged, with amateur astronomers and stargazers closely following updates on the star's behavior. This shared fascination underscores the unifying power of space exploration and the innate human desire to understand our place in the cosmos. Betelgeuse's story is a microcosm of the universe's broader narrative, a tale of constant change, where creation and destruction are intertwined. From its fiery birth in a stellar nursery billions of years ago to its impending cataclysmic demise, Betelgeuse has been a beacon of scientific curiosity and inspiration. As we await the final chapter of this colossal star's life, the lessons it teaches us resonate far beyond astronomy. Betelgeuse reminds us of the interconnectedness of all things, from the smallest atoms forged in its core to the galaxies that stretch across the universe. Its eventual supernova will not only be a moment of scientific discovery, but also a profound reminder of the impermanence and beauty of the cosmos. In the meantime, as Betelgeuse continues its journey toward its ultimate destiny, it serves as a celestial timepiece, marking the vast timescales on which the universe operates. For now, we watch, we learn, and we marvel at the universe's grand theater, knowing that when Betelgeuse finally explodes, it will leave behind not just the remnants of a giant star, but also a legacy that will inspire generations of scientists, dreamers, and stargazers to come.